We're going to calculate the freezing point of a solution using the density of the solution and the molarity. So the problem is a 1.3 molar solution of magnesium chloride has a density of 1.06 grams per milliliter. And I ask you, what temperature will it freeze at? Well, it'll make our problem a lot easier if we assume we have 1 liter, because we have molarity, which is the number of moles per liter, and if we know we have 1 liter of solution, since it's 1.06 grams per milliliter, we can figure out the mass of the solution and work from there. The reason we can do that is because whether it's 1 liter, 2 liters, 5 liters, or a half liter, the ratio of solute to solvent is going to remain constant for a true solution. So, if we assume we have 1 liter, that's 1,000 milliliters of solution, 1.06 grams per milliliter, we have 1,060 grams of solution. Since we have 1 liter, we're assuming, and we have a 1.3 molarity for magnesium chloride, that means there's 1.3 moles of magnesium chloride that would be present in that liter. So multiplying by the molar mass, which I just calculated out right here, of 95 grams per mole, we see that there would be 124 grams of magnesium chloride in the solution. Since the whole solution weighs 1,060 and the solute weighs 124 grams, the remainder would be the mass of water. So you have 936 grams of water present. So, using that, we can plug in for the molality, show the kilograms of water, we know the moles of magnesium chloride, so we can calculate the molality of the solution and use that to calculate the change in freezing point. So, once we calculate the molality to be 1.39 moles of solute per kilogram of solvent, we plug that in. 1.866 is just the freezing point constant. And 3 represents the number of solute particles that the compound breaks into. And we get that number from MgCl2 because there are 3 ions that are going to separate when you dissolve it in solution. So 1.86 times the molality times the number of particles it breaks into, that means the freezing point will change by 7.76 degrees Celsius. Since the change in freezing point is going to be a lowering of the freezing point because it's freezing point depression, that means the normal freezing point of 0 will drop by 7.76 degrees, giving you a final freezing point of negative 7.76 degrees Celsius.